What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we're looking at lesson 7.5, proportional relationships. So we'll be able to write equations for proportional relationships, graph them, and be able to apply them using word problems. The first thing we want to know is, what is a proportional relationship? That is when x and y are proportional, and their relationship can be represented by the direct variation equation of just y is equal to mx, where m is that constant of proportionality. So you're going to see a lot of like y is equal to 1/2 x or y is equal to negative 5x. There's only going to be one number here. There's not going to be any plus b like we saw in the previous lesson with our y-intercept. And that graph, because there's no y-intercept, is always going to go through 0, 0, which is the origin. Your slope is going to be represented by m. So that's the constant of change, okay? Once you get these filled in with your notes, go ahead and click play so we can move on to our next little information piece. So to write the equation of the line, we're going to find the slope first as rise over run. So we'll always start, what you can do is start at 0, 0. Then move right to the next. We're going to call it perfect point, okay? And we'll talk more about what that means in just a second. But once you do that, that is your slope, and then you can write it in the form of y is equal to mx, where m is your slope. So what we're going to do here is start at 0, 0 to write my equation of the line, and I'm going to move to the right until I find my next perfect point, which looks like it is right here, okay? So I need to find my rise over run. My rise, remember, is just going to be up or down. And then my run, in this case, is just going to be to the right because I'm going to start with my left and go towards the right. So my rise, count with me, is 1, 2, 3, 4, 5. And because I go 5 down, that's negative 5. And then my run is 1, 2, 3, 4. So my slope here is negative 5 over 4, which means I can plug it in and say this equation will be y is equal to negative 5/4 x. Okay? Next up, write the equation of each line. If you want to pause here and try these on your own, you can. Otherwise, you can keep working with me. We're going to start at the origin first, and we're going to find the next perfect point up the line, which is actually very, very close. So this is a rise of 1, and run 1 here. So my answer could be y is equal to 1x, or you could just write y is equal to x. Keep in mind we're not doing any plus b, which is our y-intercept, because b, being the y-intercept, is equaling 0. That's where it's crossing over the y-axis. So anytime I add 0, if I added 0 to this, y is equal to 1x plus 0, it's still going to be 1x. So that's why I'm not adding it in at all. Here's our next one. See if you can try the next one on your own. Start at 0, 0, find the next perfect point, and then see what you get. All right, my next perfect point I'm seeing right here, so not too far. So I'm going to go down 1. So that's a rise of negative 1, and then run 2. So my slope is negative 1 over 2. So my answer for this equation is negative 1. Y is equal to negative 1/2 x. Okay? The next thing we're going to talk about is our reminder from the previous lesson, 7.4. Remember, you have y is equal to mx plus b, where m is the slope and b is the y-intercept. So what we're going to do is start to graph these. Notice I'm only given slope, which means the y-intercept, which is your b, is equal to 0. So that's where we would start first. I'm going to start at 0, 0. There's my y-intercept. And just like yesterday, I'm going to graph my slope. My slope is negative 2. And since there's no number underneath it, I'm going to put a 1. So this is meaning I am rising negative 2, which means I go down 2. And this is my run, which means I go to the right 1. Okay? So starting here, I'm going to go down 1, 2, run 1. Next point, down 2, run 1. Next point, down 2, run 1. Just as a reminder, you can still build points on the other side of the origin if you just go in the opposite direction, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. It'll still show that same pattern. The next thing you do,
Oliver Thorpe, your ride is waiting for you out front. Oliver Thorpe, head outside.
is just connect all those points so you make that straight line, okay? See if you can graph these two. Go ahead and pause the video here, starting with your y-intercept being 0, and then graph your slope. So this first one, slope, my rise over run. I'm going to rise 5, but no number underneath. That means I'm going to run 1. So here, starting at 0, rise up 1, 2, 3, 4, 5, run 1. And that's all you really need to plot here. If you want to go backwards and create a line down here, that'd be just down 5 to the left of 1, but these 2 points are perfectly fine, okay? The next one I have rise 1, run 5. So start at 0, 0, plot that point, rise 1, run 5. This one's gonna be a super slow moving line, super not as steep as the last one, but still very kind of close together, okay? Your straight line was probably a lot better than mine. The next thing we have is using slope in a word problem. So you earn $20 per hour mowing lawns, write an equation to represent the situation, then graph it. $20 per hour, that's your constant of change, which means that is your slope. So if my slope is $20 per hour, my equation should say y is equal to 20x. So when I graph this, I want to maybe show my x and my y axis. So here's my y, here's my x. Remember, x is always your starting variable, your independent variable. So in order to make money, I have to work some hours, right? So this could be 1 hour, 2, 3, 4, and this would be my money. For every hour, I'm going to go up by 20s. So I'm just going to count by 20s. This is 20, 40, 60, 80. So hour 1, $20. Hour 2, $40. Hour 3, $60. Hour 4, $80. Notice I'm still making that straight line, and my line should go through the origin. Okay? Next up, see if you can try this one. It says, during the first snowfall of the year, snow falls at a rate of 1 inch per hour. Write an equation to represent the situation. First thing you want to know is, well, what is my slope? That's my constant of change. My slope is 1 because it's 1 inch per hour, so that is y is equal to 1x. So again, my x-axis has to be what thing that is starting. That's my independent variable. My y-axis is my dependent variable. So what has to happen first? The time has to go by. So this is my hour, and these are my inches of snow. Okay, so after 1 hour, 2 hours, 3 hours, 4 hours, I should have 1 inch, 2 inch, 3 inch, and 4 inch. So each of these are going to be matching up 1 with 1, 2 with 2, 3 with 3, 4 with 4. So that by the time I'm done, my rate of change is rise 1, run 1. The last one represents the graph is the amount of money that Joe earns. Find and interpret the slope. So it looks like I am starting at 0, 0, or I can maybe find my most perfect point. I'm going to say here. Okay, so I'm looking like I'm going up by 25s. So this is 25 money dollars for 4 hours. So my slope is 25 over 4. Interpreting that just means earns $25 for 4 hours of work. Okay? The y-intercept should be 0, 0, which means interpreting that would say for 0 hours of work, Joe earns 0 money. Okay, that's all it's asking you to do. That'll conclude our lesson on proportional relationships for 7.5. I hope this video helped you clear some things up about what a proportional relationship is, how to graph it, and how to interpret it. Thanks for tuning in so much, and we will catch you next time. Have a great day.